Morning, gents. We are moving on to diodes now. So we have talked about ohmic devices so far. So ohmic devices are the ones that follow Ohm's law. The voltage current graph is a straight line. Today we're going to look at some devices that are made of semiconductor materials like silicon, germanium, and their graph looks like this. You can see that it's definitely not a straight line, and it is different, very different. So let's actually see what happens. So first of all, a diode has two ends, a positive end and a negative end. So we need to understand what does it mean by a diode being forward biased and a diode being reverse biased. So forward biased means when the positive end of the diode in a circuit is connected to the positive end of the battery. So here's the positive end of the diode, and you can see it's connected to the positive end of the battery. So the diode is forward biased. So let's have a look at this section of the graph where voltage is positive and the current is there up there. So the first quadrant. So that is the graph of what happens to the current in the circuit if the diode is forward biased. You can see that up to 0.4 volts. So if the potential difference in the circuit or across the diode is up to 0.4, there's very little current in the circuit. However, once the voltage reaches 0.4, it shoots up. So the current increases, but you can see now the voltage isn't increasing. So if this diode is in the circuit, let's say you're applying 10 volts, the diode will only have 4 volts across it. So the rest 10 minus 0.4 will be 9.6. So the rest 9.6 volts will be shared by the other resistor, whichever is in the circuit. So a diode, when it's forward biased, so what does the forward biased diode means? That the positive end of the diode is connected to the positive end of the battery. When a diode is forward biased, ideally it has zero resistance, but it needs a minimum potential difference for it to function, and that is called the switch on voltage. So switch on voltage is the voltage at which the diode starts conducting when it's forward biased, and the value of that depends on the material that the diode's made from. After the switch on voltage, the potential difference across the diode does not increase. So even if you're applying 10 volts in this circuit, the diode's only getting 0.4. The rest is being given to the other resistance. If you're applying 20 volts to the by the battery, diode will still only get 0.4. The rest 19.6 will be given to the other resistors in the circuit. So diode acts like a voltage controlled switch. It works if it's forward biased, and the potential difference across the diode is fixed no matter what. Now, let's have a look at reverse biased. Reversed bias means when the positive end of the diode is connected to the negative end of the battery. So positive end of the diode is connected to the negative end of the battery. Now, the diode has infinite resistance in this position and it does not conduct. So you can see here, this part of the graph is the reverse biased one. You can see up to negative 50 volts, like pretty much there's no current in the circuit. Now, what happens after 50? If you apply 50 volts or more, or really high voltages, what happens is the diode breaks down. It loses its characteristics. So it's no longer a diode now, and it'll start conducting. But that means you've broken down the device and it won't function. So if you apply really high negative voltages, the diode will just break down and start conducting. However, typically, when it's reverse bias and you're not applying that high voltages to break it down, the diode will not conduct and it'll act like an open switch. So this circuit, there will be zero current in the circuit because the diode is reverse biased. The positive end of the diode is connected to the negative end of the battery, and the diode will not conduct. So it acts as an open switch. No current will flow in the circuit. So diodes have two important properties. They act as a switch. They conduct if they're forward biased, and they don't conduct if they're reverse biased. So you can control the circuit. And the second important property is that the potential difference across the diode is fixed. Once it reaches the threshold voltage, the switch on voltage, after that, the potential difference across the diode does not increase. It remains fixed at that value. And this is the symbol. The triangle is the positive part and the little line is the negative part. So for any diode question, the first thing you check is it connected forward biased or reverse biased? Now let's deal with this question. So we have a circuit, series circuit with a 150 ohm resistor and a diode. So the first thing you check is this is the positive end of the battery and it's connected to the positive end of the diode. So we know that it is forward biased. If it was reverse biased, I'd just directly say that the circuit won't work. It's an open circuit because current won't flow. Diode has infinite resistance. It's not actually an open circuit, but the diode would not have conducted if it was connected reverse biased. So this is a forward biased. Now we know that the switch on voltage for this diode is 0.6. So we can see from the graph. So I'm going to write 0.6 here. So whatever is left over, so what will be the potential drop across the 150 ohm resistor? 12 minus 0.6, that means that resistor will get 11.4. So now all that the diode is doing is it's taking 0.6 out of the 12 volts that you're supplying, but now it has no further resistance. It has no resistance now. It acts as if it has zero resistance. So if you were to find the current in the circuit, Ohm's law, you can use I equals V over R. Now, you only deal with the potential difference with the resistor. So the resistor is getting 11.4 and the value of the resistance is 150 because the diode has no resistance now whatsoever. It just took 0.6 volts from the battery and now we drop that 0.6 and we pretend as if the diode's not even there. So we now consider it as an equivalent circuit that there's a 150 ohm resistor getting 11.4 volts from a battery and the diode is not even there. So this is the value of current in amps, or we can say that it's 76 milliamps. So this is how you deal with the diode questions. If it's forward biased, just minus the switch on voltage from the power supply and deal with the resistance as so just the leftover voltage is given to the resistance and use the Ohm law to find the current in the circuit. And that's pretty much what you need to do with diodes.